BC students, you know what you're doing. AB students have quizzes. I will cut off fingers and tongues if anybody shows a quiz to Sylvia or Gonzalo. Okay. Stress levels might be a little bit high. Okay. How many of you have just received a quiz grade that you're not satisfied with? You think you can do better? How many of you are pretty sure it's because of the free response? Because your notation stinks! Because somehow I have not made it clear how important your ability to communicate your thoughts are. Okay.
I'm not good at expressing.
If you are dissatisfied with your quiz grade, today during lunch I'm available to help with the corrections process. Monday during lunch I'm available to help with the corrections process. After that, the grade is locked in for EVs.
Can you fill in like the correction process?
Can I fill in the correction?
Like make a video.
Can I make a video? No, because it's a quiz.
Oh.
And I don't want it out there in the world. Was that,
how many grades are you gonna put into for the report card?
all of them?
Well, like, are there more? How many are left?
Are there more? Yes. There's a test next Friday.
What do you put the grades are due next Friday?
That's fun. Woo! Test next Friday. There's going to be, wait. Let me connect you back to the homework. Tonight's homework, which is actually due on Tuesday, is the first one being collected for a grade in a while. Yeah, okay, so let's take out the agenda here. The assignment is number 15, assignment 15. You're going to do all the problems. Floor, you look like you're ready to barf. Okay, assignment 15, all the problems are due Tuesday for a grade. The smart people, Chris, I can see you already wanted to make a comment. You're like, Chris was about to say, I think all the smart students are going to get started this weekend. Yes, Chris, I agree with you. Chris, that's what you were going to say, but you have something else to say now. Today during lunch, Monday during lunch. Eval.
So there's going to be a retake if you did the correction?
It's not a retake. It is just come in here, let's talk through corrections, let's talk with you what the free response should have been, and let's get it fixed. And points can come back for that. Okay? Roberto? Do well in the test, and the test grade can replace the quiz grade. Okay, yep.
What if, like, your strongest factor was free response, but it was multiple choice?
Oh, we're going to work on whatever corrections you need to work on.
Okay.
But probably my time is going to be spent with folks that really didn't know what to do in the free response part of the quiz. Eval, last question.
So if you get a passing grade, then you want a higher grade, can you still do it?
Anyone can come and work on corrections. I'm not Mr. like you can make corrections to get to a 70. I care much more about passing. Passing is too low of a bar for the 28 of you all. Like, I want to be like B and higher. Because you're all DeRosiers now, so like anything less than an A, not good enough. Welcome to the family. That's how we roll in the DeRosier home. All right, so let's get rocking and rolling. Paul, are you ready to take instruction?
Yes.
Excellent. Everybody, I said what the homework was, right?
Yes.
Okay, good. Good. All right, so we've got geometry sketchpad up here. You need to be on page 38 in the unit guide. What I want to do, and Karina, we're filming, right? Okay, we've been filming for a while probably.
Okay.
Page 38. You should have a blank page in front of you. Not blank, but you got some stuff on there. And I want you to sketch this graph on there. You've got plenty of space to do this. Don't get all OCD on me. Your graph doesn't have to look exactly like mine. But I want to have a conversation about what's happening in our friend Sir Isaac Newton, God rest his soul. Sir Isaac Newton, really, really interested in tangent lines. Can somebody remind me tangent line? What makes a tangent line a tangent line? Jeanette. It touches the graph just once. Not pass through the graph, but like touches, just glances off. So the black line here is a tangent line. And for the vocab moment here, the place where the tangent line touches the graph, we call this? Curve. Not a curve, we call it the point of tangency. Way to be there for me, sister. Okay, everybody okay with the point of tangency? We've got the tangent line. I want to find the slope of the tangent line. What's the problem? Why is it so hard to find the slope of the tangent line? Andy?
Because you need another point.
Because right now, all you know for sure is 1 point, and you need a second point to find slope. And everybody's okay with this?
Yeah.
So somebody tell me, what was Newton's idea? What did Newton say to do? Paul?
Make a secant line.
Make a secant line. What's the difference between the tangent line and the secant line?
It touches the graph at 2 points.
It touches the graph at 2 points. So I pick another point over here, and I'm going to connect the two. Wow, those didn't connect, but let's pretend that it did. And there's my secant line. And so Newton said, just find the slope of the secant line and you're done?
No.
Karina, what did Newton say we needed to do?
Put FC minus FC.
Well, forget about like a formula. What did he tell us to do? The blue line is the secant line. The black line is the tangent line. What I want is slope of the tangent line. Diego, what do we do?
Instead of bringing the second points closer to the point of tangency.
Bring the second point closer to the point of tangency, like over here? Like over here? How close do we need to get?
To the point that you think is touching.
To the point where it's like these 2 points are so darn close they look like 1 point, right? That's the notation of limits. This is where limits comes in. Is everybody totally okay with this? All right, so we're all going to ooh and ah appropriately as Paul hits the right buttons here. Okay, Paul, click on tangent segment at P.
Ooh.
He hasn't done much yet. Okay, so here's my little tangent segment. Tangent because it touches it once. Anybody know the slope?
2.819.
2.819. Jackie, that was really impressive. That is exactly the slope. Oh my God, brilliant. We should test her for being absolutely brilliant. Or reading. Okay, now here's the thing. Newton, back in the 1600s, did not have Geometry Sketchpad. He did not have a laptop. He did not have electricity. Geometry Sketchpad is just helping us out. So here's the tangent line. Great. Paul, what we're going to do is we're going to create Q. Here comes Q. Q is some other point on the curve, and I'm going to label this x, comma, f of x. My point of tangency is going to be a, comma, f of a. And what are we supposed to do next? We're going to create a secant. Here's secant line PQ. And Jackie, of course, knows that the slope of PQ is
4.285.
4.285. So these are the same? They have the same slope, Adrian? The tangent line and the secant line have different slopes. How do you know?
They're different numbers.
Clearly they're different numbers, but wouldn't you also expect they're going to be different? Even if I took the numbers away, wouldn't you expect they're going to be different?
Yeah.
Right, we're talking about two different lines. So here's where things really get magical. What I want to do is what I think Diego said, let the second point get closer to the first point. And what should happen is as the second point gets closer to the first point, let's see what happens with the slope. So Paul, click let x approach A. And Paul, hit it again. Check out what's happening with the slope of PQ. PQ is the secant, right? Okay, do it again. Stop. How are we feeling?
You have to get more closer, right?
We are getting closer. The slope of the tangent line, the computer knows is 2.819. Using these 2 points, the slope is 3.074. Pretty good. Could we get better?
Yes.
What do we do?
Go closer.
Closer. Paul, closer. Ooh. Do we think Paul can get better than this?
Yeah.
Okay. Go, Paul. Oh, epic fail, Paul. Okay, Paul, let's see how well you can go. Oh, Paul's getting nervous now. Oh! I thought you were trained. Last time, Paul.
Huzzah!
That's pretty good. That's pretty good. That's pretty good. Pretty good?
Yeah.
All right. So, take a second. What's the formula? What's the formula for finding the slope of the tangent line at x equals 8? Don't tell me, write it down. Don't tell me, write it down. Yep. Correct. Your goal is always what you want is tan. Karina, can they see if I'm over here? Our goal is to find the slope of the tangent line at x equals a. The formula is always going to look like f of x minus f of a over x minus a, and we take the limit as x approaches a, and I hope everybody's okay with this. This is the slope of the tangent line at x equals a. This is the formula. Yesterday you guys had some problems that you did. I said, hey, find the slope of the tangent line at x equals 4, and then it was limit as x approaches 4, f of x minus f of 4 over x minus 4, and we evaluate and we go and everything's good.
Yes.
Everybody okay? So that's one way. A notation better than this tan at x equals a. You've seen this before. It's called f prime of a. What's it called, everybody?
F prime of A.
F prime of a. This is known as the derivative of f at x equals a. Tan at x equals a, it's fun to say, but it's really the same thing Chris is saying, f prime of a. It's the same thing as when I say go find the derivative of f at x equals a. It's all the same thing, it's just different ways to say it. Everybody all right? Okay. There is another formula, and Paul, if you can move point Q far away. So just let x, there we go. There's another way, and this one I want you to get in your notes. I don't want to obsess about this one too much, but there's another formula that sometimes the College Board uses. I've not used it a lot, but I want you to know it. I want you to see it. They look at the second point a little bit differently. Rather than calling it x comma f of x, they say I'm going to go a horizontal distance. Let me call that h to get to this second point. And then I'm going to go up or down to the curve. I'm starting at a comma f of a. I'm going to go a horizontal distance of h to the right, or it could be to the left. We want to consider both here. So what are the coordinates of q? Take a second. Think about the geometry here. You're starting at a comma f of a. The coordinates over here, I see 1, I see 2, I see 3. You're starting at a comma f of a, and we're going h spaces to the right. Val, what are those coordinates?
Oh, the actual coordinate. Wait.
You're starting over here at a comma f of a of your point of tangency. We're going h spaces to the right.
So is that a plus a?
So the x value is going to be a plus h. The y value is going to be f of a plus h. I need to think about the setup there. The point of tangency is a comma f of a, and you went h spaces to the right, which means you've changed your x coordinate by adding h. To get the y coordinate, you're going to evaluate your function here. Now what happens in this other version, to find the slope, you're going to write f of a plus h minus f of a over a plus h minus a. I hope everybody's okay with that. This is just slope between 2 points. What's different is how you write this next part. How would you write that these 2 points are getting closer to one another? Way close to one another. What has to happen? Marilyn? Okay, we definitely need a limit. Limit as what happens? You're starting at the point a comma f of a. H is saying go h spaces to the right. And I want these 2 points to get way close. H approaches P, not P.
A.
H isn't approaching P, it's not approaching A, Henry? Okay. H is the distance between these 2 points, the horizontal distance. I want that distance to get small. How small? Not infinity is big.
Negative.
Negative infinity is big negative.
Oh.
I want H to get small.
Zero.
Zero.
H has to approach 0. So your setup would be limit as h approaches 0. This still means tan at x equals a. This all still means f prime of a. This, I think, is like option number 1 when I think about working with derivatives. This over here is option number 2. They give you the same thing. They all tell you slope a tangent line. All the great things happen, Adrian. They just look a little bit different. And in fact, really, if I'm going to go with this version, I'm going to clean it up a little bit. A plus h minus a. Those a's are going to cancel out. And we get the limit as h approaches 0, f of a plus h minus f of a all over h. And this might start to look familiar for all the pre-calculus friends.
Yeah.
You've seen this before.
Yeah.
Okay. Big picture, we're mostly okay? All right, so I want to stop with the new stuff and give you a little bit of practice. Diego, I saw you kind of wave me off there. All right, so we've got a nice little model problem that I want you guys to start with. You're going to work with the folks around you. I'm going to walk around and see how you're doing. I'm at the top of page 39. This is what a question on the test, on the quiz, might look like. Find the slope of the tangent line to the curve f of x equals the square root of x at the point x equals 4. What does this tell you about the behavior of the curve at x equals 4? Get started, get some help from the front friends around you. If you need me, I'll help too.
You're still smart.
Well, thank you for all you did. Oh, so close. Camry.
Yeah, make sure that when you plug it in.
So we have an X of 4. What do you mean?
I need you to find slope of the tangent line at x equals 4, and Daisy has successfully earned the first point. This is a 4-point problem. Daisy's got the first point.
Yeah.
Nicely done. Gerardo has earned the first point. Karina's got the first point. Excellent. Gonzalo's got the first point.
I have a question. How to define f of 4 if you don't give us a point?
But f of x is the square root of x. So what's f of 4? 2. And Jackie's almost got the first point. Okay. Marilyn likes pain too.
Oh, got it.
So
Square root of x, we can. Well,
if you haven't set it up yet,
the one on the bottom.
limit as x approaches 4, f of x minus f of 4 over x minus 4. That's just the formula. So Jeanette, that's the formula specifically at x equals 4. F of x minus f of 4 over x minus 4. Some people have made it further, and they said, oh, well, what's f of x? That's the square root of x. F of 4 means find the square root of 4, good news, 2 over x minus 4. Really, that's probably where I award the first point. And now the good news, all you need is some limit skills. And we've got limit skills. how are we going to evaluate this limit? There needs to be a whole lot of people ready to jump in and do this. I'm worried that there's only 2 people. I'm not going to help yet. Talk to the folks around you. I'm not going to help anybody.
That's what I'm saying. But people said no.
I didn't know. For me, I did it like this.
Just plug in 4. You're going to square root of 4, which is 2 minus 2. 4 minus 4, you get 0 over 0. It's not
That's
an
why
answer.
I factored this.
And you do X more.
Chris, any good ideas?
Accurate.
You can't.
You do not factoring.
That's fine. X and X.
But how do you take away the square root of
Because
X?
the square root
There's
is
only
1.
one X.
This is 1, right?
The fact that there's a square root is a clue. You've got the square root of x minus 2 over x minus 4. There's something you want to do to evaluate this limit.
I mean, I find it easy like that.
Multiply by the conjugate.
And that's how I created myself.
Yeah, I can't do that because like the one have like pieces and like where does the 1 go, where does the 2 go? Because I don't do that.
It's like, say we have this, right? And we let's say 4. Yes or no? And then we have this 2 right here, right? Same thing as saying 2 and 1/2. The 2,
Like, I will remember that right now, but then the other one, like, I forget.
At first, we were 2, I would do that. And then you go in on. I mean, you can do that. Wait, is it like this?
Oh, so you factored. Clever.
They cancel out. Square root multiply, you get square root of
It's totally your choice. I usually go to the top one. Either way you go, you're going to get to the same answer. You're going to get to the exact same
But
answer.
when it comes to that, how do you know what to put in the? How do you know what to put in the fancy one? How do you know what to put in the fancy one?
Why? So the reason for the box
Oh,
is
the
to help
fancy
you
one?
organize your multiplication.
So like, if it's
So
the
the
top one,
area
like,
from each
it's
box,
like
you're
square
going to
root
height.
of like x minus 2. If you do the opposite, so like the 2 square root of x cancel out.
Yeah.
No, it's like the thing is saying that.
Well, because, and I think this is the part that you're not seeing, Sylvia, is over here I'm multiplying by the conjugate, I'm multiplying by square root of x plus 2 square root of x plus 2. I put that in because that's how we can get around these square roots. You're just multiplying by 1, so it's legal, and then I just went off on the side and I did the multiplication. All right, friends, whether you got it on your own or you've copied it down off of me, the answer is 1/4. How many guys honestly came up with 1/4 on your own? 1, 2, 3, 4, looks like about 8 or 9. Okay. Number 1, stay with me on this. It is mission critical. Oh my God, mission critical that you know that when I say find the slope of the tangent line at a point, that this is the setup. After that, it's going to be your limit skills. So if you're still struggling with evaluating limits, we have got to get this under control. You cannot just put your blinders on and say, oh, I don't get limits. Limits are a part of calculus. So for those of you that knew to multiply by the conjugate, you're going to get x minus 4 in the numerator. That cancels with an x minus 4 in the denominator. Life is good. You're going to evaluate the limit. Finally, you're going to get 1/4. Hold on, Jackie. 1/4 is the final answer.
No.
No. Why not, Henry?
Because you have to write that sentence. It says like m10 of x equals 4 at the no. X equals 4 equals 1/4, meaning that the graph is increasing.
Okay, so first of all, let's go back and actually figure out what's the question that we're trying to answer here. Rebecca, what's the question we're trying to answer?
I just know that this is
What does it tell you about the first?
Okay, what does the fact that the slope is 1/4, what does it tell you about the curve? The curve that you don't see, the curve that is not provided, what's the thing that we know? 2 people? 2 people? 3 people? 4 people? Jackie, what do you know?
Isn't it increasing?
What's increasing?
The slope? The curve.
There you go. It's not that the slope is increasing. What's increasing?
The curve.
You could even say like the graph or the curve, the graph of, name the function. F of x is increasing. Be specific.
At x equals 4.
At x equals 4. It is mission critical that you name the function, that you describe the behavior, and you tell me where it's happening. Jackie, what's up?
Could you go in with like a red marker and tell us like what would get you the point in this equation?
Oh, it really kind of depends from problem to problem.
Okay.
But I would say being able to do the setup, I'd award a point.
Okay.
Successfully multiplying by the conjugate and getting here, probably another point. Coming up with the numerical answer, a fourth, a third point. Coming up with this whole statement would get you the 4th point.
Okay.
This would be all of it. Evel.
If you factor the denominator instead of multiplying by the 1, can we still get the
Absolutely. So Karina chose to factor the denominator as well and get to the exact same 1/4. I'm going to accept multiple pathways. Just get to the 1/4 correctly. Everybody good? All right, let's keep going. All right, now that you know the slope of the tangent line to the curve, find the equation. Find the equation of the tangent line and call it L of x. Well, yesterday we talked about my favorite formula, point-slope form. Much better than slope-intercept form. Y equals mx minus x1 plus y1. So in this case, I want you to call it L of x. The slope is 1/4. X minus 4 plus
2.
the y value. Right, we're talking about the point of tangency. And so the function was f of x equals the square root of x. We were at the point where x equals 4. What's the y value? 2. So that's going to be the equation of your tangent line. Not too bad. Okay, Chris.
How many points would you get at that first?
Oh, you guys are so good. Okay, you ready?
Yeah.
1. 1. All the hard work comes in with part A. All right, part C, I want you guys to read through this and graph it, and so we can have a little conversation about why do we keep talking about these tangent lines? There's something really big going on with the tangent lines that we need to have some conversation about. We'll talk in a little bit.
So to get to just plug in 4 to the to get to just plug in 4 to get the original one. It's because since we said that like 4, right, which is just what we have, but if you plug in 4 to everything, you
So you have the equation and it tells you that x equals 4. So you have to look for y.
So don't we just like,
So you know I gave you the equation.
Yeah, it's important.
yeah. You seen how close it
Because
is?
we're using L
Well,
square root of
that's right. You put the equation and then you plug it in and subtract.
No, I was at, also this is a real y.
This is the reflection of your glasses that look purple.
We're going to talk about that in a second.
She doesn't have
All right, friends, let's pull this together. So here's what I've seen on a couple of papers. We've got the graph of f of x equals the square root of x, a parent function that we all know and we know well. We all should know this well. Here's the point x equals 4. I'm just making it up. Here's the point 4, 2. Can you guys show me with your arms, where's that tangent line going to be? What's it going to look like? Where's that tangent line? Over here?
Oh,
Should be over here, right? So the red is the tangent line, L of x. The black is the original curve. The red is the tangent line. Jackie, I see you. Give me a little bit here. And 4, 2 is the point of tangency. I want to make sure we've got all the vocabulary here. Point of tangency, curve, tangent line. Where would 4.3 be on this graph, Andy? 4.3. Well, x equals 4.3.
Oh,
A little bit to the right. Okay? Maybe that was an exaggeration. If I said, where's f of 4.3? I would hope everybody would go up to the curve and say, oh, well, there's the point 4.3 comma f of 4.3. Are we okay with that? Sure. The tangent line, though, gives you a greater value or a smaller value?
greater.
A greater value or a smaller value?
Depends.
The tangent line at 4.3, bigger or smaller?
Bigger.
This is bigger.
Look at the graph. This is the point 4.3 comma f of 4.3. It's whatever the y value is there. But the tangent line is up here. So on the tangent line, that's 4.3 comma whatever the y value is. It is higher than it would be on the graph.
Yes, sir.
So are you getting an overestimate or an underestimate?
Overestimate.
You're getting an overestimate. Overestimate because at x equals 4.3, the tangent line, L of x, has a greater value than f of 4.3. Overestimate, because the tangent line is higher at that point than the curve is. The difference between these two, that vertical distance, is the error in the estimate. It's how much you're off by. This is the thing. If you are close to the point of tangency, your error, not too bad, right? Your gap is small. But if I said, hey, approximate like out here at x equals 9 or x equals 10, the further out you go, the bigger the gap's going to get, the bigger the error is going to get. Are we okay? So here's what would have happened back in the day. Back in the day of Newton, before there were graphing calculators, somebody might say, hey, I need an estimate for the square root of 4.3. And they did not go to their TI Inspire. It wasn't out yet. They didn't go to the TI-84. They didn't go to the TI-1. There was no TI-1 back in the day. They had to use their brains. Square root of 4.3. Does anybody know anything about the square root of 4.3? Roughly where it is? Somewhere between 2 and 3. Right, that's an okay estimate. The square root of 4 is 2, the square root of 9 is 3. I want a better estimate. Yeah?
Couldn't we change it to 1/2 and then 1.3 on the top and 1.3 2 times on the bottom?
So I hear you saying 4.3 like to the 1/2 power, but 4.3 to the 1/2 power is not the same as saying 4.3 times a half. So here's what they would do. They'd use the tangent line. If you use the tangent line, L of 4.3, let's plug it into the tangent line. The tangent line said take 1/4, your x value minus 4, plus 2. Remember L of x in part B, it was 1/4 x minus 4 plus 2. The tangent line approximation, L of 4.3, says take 1/4 of 4.3 minus 4 and add 2. You're not allowed to use your calculator. We're in the 1600s. Nobody has a calculator. 4.3 minus 4?
0.3.
I'm being kind here. 4.3 minus 4 is 0.3. 1/4 of 0.3 is not 3/10.
4/3.
No. 1/4 of 0.3.
Oh,
Point one.
Undefined.
No, honey, it's defined. 1/4 of 0.3. I'm gonna give you a second to go back into like 6th grade mode here. What would you have done back in the day in 6th grade without a calculator? Henry, what might you want to do?
Is it?
0.012.
Yeah.
3 over 4.
It is not 0.12. No. Oh my sweet Lord. It's like an auction with not smart people. It's not 0.6.
75,000.
It's not 0.065.
0.012.
It's 0.075.
Whoa.
Is what?
Where did 0.075 come from?
Oh, you had the word.
You didn't say loud enough.
Oh my gosh. I'm going to let you guys stop embarrassing yourselves on camera here. 1/4 is the same thing as 0.25.
Oh,
0.25 times 0.3. Forget about the decimals for a second. 25 times 3?
75.
75. How many places do you move the decimal?
3.
3.
so what number is that?
So 0.075 plus. Next. Good thing you all don't live in the 1600s. I don't think you would have survived for too long. So here's the thing. Stay with me. Using your tangent line approximation, you get 2.075. Take out your calculator, you like fancy exotic people here. What's the square root of 4.3? Back in the 1600s, nobody could go to their calculator. They would say 2.075 using this tangent line is a good approximation. Sylvia, what do we get? Square root of 4.3, what do we get? Oh, you're still going for the calculator. Paul, what do you get? 2.07364. 2.07364 is approximately the square root of 4.3 on the calculator. Not being able to find a square root, if I just find my tangent line approximation, we're getting 2.075. Overestimate or underestimate? Over, we already knew that. How good of an estimate is this?
Good.
This is way good.
We can do good.
We could absolutely do better. But that would involve doing a quadratic approximation, which is a Calculus BC topic, and so we'll hold off on that for now. Hey, good luck, friends. All right, we got about 10 more minutes. I want to push your thinking a little bit more.
Can't relate.
Because, why not? So if you guys can flip over to page 40. Wow.
So like on that, we don't have to write any kind of number, like proving.
Wait, what?
Like we already know it's an overestimate.
We already knew it was an overestimate, Henry. Why did you know it was an overestimate?
Because it was like in front of the one we're looking at.
Not because it was in front, it was about the graph. It was above. The tangent line was above, that's why it was overestimate. Andy,
So we do the graphic still have to do all this?
that would be a good idea. Okay, we got about 10 minutes left. All the friends still okay?
Yeah.
I got one more thing. One more tool in the toolbox here. I want to come back to this same diagram, and I want to make it more powerful. Okay? You might be thinking, gosh, we've already seen this graph. It's just an example. It doesn't matter. I want to label point P differently. Every time we've labeled it so far, I called it like A comma f of A. I want to label this point as x comma f of x. X can represent all values. Not a specific value like 2, but it's any point on the curve. What I want is to find the slope of the tangent line. And I think you guys know 100% exactly what we're going to do to find the slope of the tangent line. What do we do? What does Newton tell us to do? Jesus, how are we going to find the slope of the tangent line? Well, we've got some equations, true. But right now, there's only one point on the curve that you know. What's the big idea here with finding slope of the tangent line?
You use the secant line to get another point.
You're going to take another point on the curve. I don't care where it is, but now you're going to make a secant line. And I want to label this one a little bit differently. Because this is the point x comma f of x, I want to talk about how far to the right or the left I'm going to go, and I'm going to label that H. In fact, we've already seen this earlier today. And then I'm going to go up to the curve. Oh, such a sad noise. If this is the point x comma f of x, and h represents the horizontal distance, then the x coordinate is x plus h. The y coordinate is f of x plus h. And then the way I find my slope, f of x plus h minus f of x all over x plus h minus x. And I hope everybody's 100% okay.
It's gonna be a lot of letters.
What was that?
It's gonna be a lot of letters.
There's a lot of letters.
It is gonna be.
F of x plus h minus f of x all over x plus h minus x. And that's the slope of the tangent line?
Don't we have to write anything?
Okay, first of all, this is not slope of tangent line.
Curve.
I will give you all no credit if you tell me this is slope of the tangent line. I want to get some hands on this. Why is this not going to tell me the slope of the tangent line? This is really important to me. 1, 2, 3, 4 people. Why is this expression right here not the slope of the tangent line? Sylvia?
Because the tangent line only goes through one point.
The tangent line would only be touching the curve at one point. We're using 2 different points on the curve right now. I don't want 2 curves, 2 points, I want 1 point. So get me to 1 point. Or anybody.
Yes, you do.
How do we go from 2 points to 1 point? We're not going to just cancel out x's. There's something that we have to do to move from 2 points to 1 little point. And we've already done this like multiple times. Jesus, what are we going to do?
Look for a limit.
You're going to look for a limit. Specifically, what limit?
As x approaches 0.
H approaches 0. You've got to be really careful with the labeling because H is the distance, the horizontal distance between the 2 points. So that's the limit as H approaches 0. Now, of course, I can clean this up. And we can say this is limit as H approaches 0, f of x plus h minus f of x all over h. And we've seen this before. Right, this is another way to find the derivative. What this is going to give me is I'm going to call this f prime of x. This represents the derivative at all points. Not the derivative at one little point, the derivative at all the points at the same time. Your answer is going to be a function. It's not going to be a number, it's going to be a function. And we get about 4 minutes. What I want to do is I actually want to use this new method, this more powerful guy here, to find the derivative for f of x equals the square root of x. So here we go. I need to find, I'm going to need more space than that. I know better. Okay, limit as h approaches 0. F of x plus h minus f of x all over h. This is because the question asks for at all points. This is what I'm going to use. Well, f is, oh, God, that noise. F is the square root function, so I need to find the square root of x plus h minus the square root of x all over h. If I take the limit as h approaches 0, what's going to happen? Let h get close to 0. Square root of x minus the square root of x? 0. Because the function that we're working with is f of x equals the square root of x.
Oh.
Okay? Is everybody okay? We're getting 0 over 0? Okay, how am I going to evaluate this limit if we're getting 0 over 0? Everybody needs to know what we're going to do here. Probably we're going to multiply by the conjugate. The conjugate is you look at the part that has the radicals and you change the sign in between. So square root of x plus h plus the square root of x. Square root of x plus h plus the square root of x. That's fancy 1. It's always fancy 1, so it's okay. Some of you, I think, are getting really good with multiplying this conjugate, and you know what's about to happen. If you multiply these guys together, do the box if you have to, or just tell me what the result is. Square root of x plus h minus square root of x. Square root of x plus h plus the square root of x. It's the square of this guy minus the square of this guy over here. So what is that? That's x plus h minus x. In the denominator, we've got an h. We've got square root of x plus h plus the square root of x. Adrian's got a big head, apparently. I need some algebra cleverness here. Jackie, any algebra cleverness going on?
Wouldn't the x on the numerators, they wouldn't cancel each other out?
Okay, the x over here and that x over there are going to cancel each other out.
And then the h with the h at the bottom?
And the h that's up here and the h that is down here, those are going to cancel?
Yeah.
Be careful, because what you're left with now is limit as h approaches 0 of 1 over what's left in the denominator. Square root of x plus h plus the square root of x. Take the limit as h approaches 0. You get 1 over square root of x plus the square root of x, which is 1 over 2 square roots of x. It's not a number. It's not supposed to be a number. What this means is that f prime of x is 1 over 2 square roots of x. Give me just one more second. What this represents, BC friends, you know what you're doing?
Yes.
Okay. This represents the slope of the tangent line everywhere. So what's the slope of the tangent line at x equals 4?
1 over 2.
1 over 2 times the square root of 4. But wait, square root of 4 is 2. 2 times 2 is 4. Slope of the tangent line is 1/4. Do we already know that?
Yeah.
Absolutely. If you go with the more powerful version, you can get a function answer and then just plug in the number at the end. So this is like a third way to go and find the derivative. Okay, this weekend's homework, assignment number 15, all the problems. It just has to do with limits and derivatives. I'll see you guys later.